Let's review what we did in the previous clip real quick. We created a network server using the nets module create server method. This server object is an event emitter, and it emits a connection event every time a client connects to it. So we register the handler on this connection event. This handler gives us access to the connected socket. The connected socket is also an event emitter, and it emits a data event whenever the user types into that connection. And it also emits an end event if the user disconnects from that server. So now we have a server. We can connect to this server, type to it, and many users can connect to that server and also type to it. No problem there. They both can write to their sockets and we can read from both sockets. These two connected clients get two different sockets. In fact, let's give every socket a unique ID. We can simply use a counter. I'm going to do counter, starts from 0. Every time a client connects, we'll define an ID property for that socket and assign it the counter plus the counter for the next socket. And now on data, when we receive the data from the user, let's identify the socket. I'm going to remove this console log line here. We don't need it. And in here, instead of writing data as, I am going to write $variable socket.id to identify it. Just like that. So let's test one client, two clients. And now when this client types, it says 0. And when this client types, it says 1. So this makes the log clear. We have two different clients connecting here, and we can write to their sockets. To make these two clients chat with each other, all we need to do is, when we receive data from one of them, we write it to all the connected sockets. So we need to keep a record of all connected sockets and loop over them in the data event handler. We can use a simple object to keep a record of all connected sockets. Let's do that. Let's define a sockets variable and start it as an empty object. Every time a socket connects, let's store it in this sockets object. Let's index it with the ID that we just defined, just like that. Then on a data event, we can loop over this object. We can use object.entries, which is actually a new method in JavaScript, just like keys, but gives us both the key and the value. So entries for sockets dot for each, which give us a handler. Inside the for each handler argument, we can destructure both the key and the socket object, which I'm going to alias as client socket here, so that it doesn't conflict with the global socket that we're working with. And now inside the for each, we can just use our previous code to write to the socket. But instead of socket here, it's going to be CS, the socket that we have in the loop. And actually key is not used, so we can just remove it. We only care about the connected socket. And I do want to keep this as socket.id because that's the socket that's actually sending the data, so it's good to identify who is writing in that case. So let's test all that. Connect multiple clients and try typing in all of them. Hello? So you'll see how 0 said hello, 0 said hello in both of them. And then hi, you'll see how 1 said hi and 1 said hi in both of them. So let's review. On data from any socket, we loop over this sockets object and we write the received data to every socket in there. This is simply acting like a chat server because every connected client is receiving all the messages from every other connected client. However, if one client disconnects, our chat application will simply crash because now we're trying to write to a socket that was closed. So to fix that, in the end event here, when the socket emits an end event, we should delete it from the sockets object. So sockets for the socket.id. This would delete the disconnecting socket from the sockets object. In this way, if one client disconnects, the other client can still type and the server will not crash. So now we can say that we have a bare bone chat server.